Hi everyone, one of you sent me this question asking for help, and I'm making a quick video to hopefully, help. The idea here is this is part B of a question on a paper 4, and luckily we don't need part A, so really I can just consider this question as a standalone question. Now, as always, I would advise you to press pause here and to try doing this on your own first, and then watch the solution. As you can see, we have a circle here with center O, and it has radius 12 centimeters. That's the radius here, OE or OD. The angle DOE, which we can see here, it's this interior angle of 40 degrees. So DOE is equal to 40 degrees, and we're told that the minor sector DOE is removed. Okay, so they've split this large disk into two sectors, the minor sector and the major sector, and they've removed the minor sector DOE. Once that's done, the major sector is formed into a cone by joining OD to OE. So imagine if this were a sheet of paper, you cut out the minor sector, and then if you pull or bring this point D to this point E, it will form the cone that you see here. And we need to calculate the height of the cone. Okay, that's our task here. We need to find this total height. Now, in doing this, the first thing I notice here is that we need to make a connection between this disk, more particularly this major sector, with this cone. And so we need to think of what our options are. The first thing that comes to mind, is to summarize the information we have. One thing I know for sure is that the circumference of the disk at the base of this cone has to be equal. It has to be equal to the arc length of this major sector. Okay, hopefully that makes sense, right? Because remember, we're removing the minor sector DOE. We're bringing D to E. So this perimeter or circumference at the base here has to be equal to this arc length. So that's the first thing I'm going to consider here. If I call that arc length L, okay, I'll go ahead and say that, okay, well, L has to be equal to, well, we know the formula, right, for the arc length of a circular sector. I'll remind you of it right now. That's theta over 360 times 2 pi r. Okay, now, in this case, theta would be the angle at the center of the major arc. In other words, that would be this angle here. And since we know that this angle is 40 degrees, the angle at the center for the major arc would be 320 degrees. Furthermore, the radius here, that's, we're going to need that for this formula, the r that we have here. Well, that's 12 centimeters. So I'll just say 12, and I'll say that the arc length L has to be equal to 320 over 360 times 2 pi times 12. I will tidy this up a bit. Maybe I'll do it in 2 steps. That's equal to, let's see, 32 over 36 times 2 pi times 12. And 32 over 36, well, let's see, that gives me 16 over 18, which gives me 8 over 9. Okay, so that's 8 ninths. L is equal to 8 ninths times 2 pi times 12. Okay, and for the moment, this is a calculator paper. I don't really need to simplify it much further. I'll just leave it like that for now. Now, now that I have that arc length, that's allowed me to use this circular sector here, and in particular its arc length, to make a connection, or rather to come up with the circumference of the cone that I have here. So now I can say that, okay, well, this circumference, which I'll just call C, is equal to this expression, 8 ninths times 2 pi times 12. Okay, it has to be. Okay, so I'll just say that, 8 ninths times 2 pi times 12. Okay, so keep that in mind. I'm going to come back to that in a minute. In fact, I'll go ahead and box that. Okay, just to make sure I remember to come back to it. Now, remember that I'm looking for the height of this whole thing. And one of the formula I know involves the height is the slant length, okay, or the slant height, sorry, of the cone. And we usually call it lowercase l as well, which is rather unfortunate here because I've already used that letter. So I'll go ahead and call this slant height, I'll go ahead and call this capital L, okay? Now, one thing we know is that the slant height, capital L, is equal to the height of the cone squared plus the radius of the circle or disk at the base of the cone squared, and all of that under a square root. Right? If you're unsure of that, just remember that if I were to project, sorry, that's not going very straight, is it? If I were to project the summit of the cone down to the center of the disk, then the slant height, this length here, is nothing more than the hypotenuse of the right angled triangle that I'm hovering over right now. Okay, so this would be a right angle, that would be the radius r, and that's the height that we're actually after. Now, this is quite useful because I can now state, if I square both sides of this, that tells me that the slant height, capital L squared, is equal to h squared plus r squared. Okay? And we know what L has to be. I didn't mention it before, but if you think of it, because we're making this cone from this circular sector, this major sector here, the slant length is equal to the length OD or OE. In other words, the slant length or slant height is equal to 12 centimeters. So the L that we have here is 12, and so this can already be written as 12 squared equals to h squared plus r squared. But now, we're getting closer. We have an expression involving h, which is looking good, but we need to figure out what r is, okay? Until we figure out what r is, we won't be able to figure out what h is. But this is where what we found earlier on, the circumference of that base, that's where this comes in handy. Because I know that the circumference is equal to 8/9 of 2 pi times 12. That's great. I also know, though, that the circumference, c, has to be equal to 2 pi times r. And so, consequently, because the circumference is equal to the expression we have right here that I'm hovering over, I can now state that 8/9 times 2 pi times 12 must equal to 2 pi r. To be clear, I've replaced the c here by the expression we have written in blue here. And looking at this, well, this is an equation which, when solved, will give us the radius of the disk at the base of this cone. Okay? Now, let's solve it. I'll cross out these 2 pi's. And now let's try and simplify this a bit. On the left-hand side there, what do we get? We have 8 over 9 times 12. Okay, well, I'll start by writing that as 8 times 12 over 9, and that's equal to r. Now, this fraction can be simplified a bit, right? 12 and 9 have a common factor of 3. And in fact, I'll write that. I can say that that's 3 times 3, and 12 is 3 times 4. And so crossing out one of those 3's, we're left with 4 and 3 there. Okay? So this fraction turns into 8 times 4 over 3. Yep, and that's equal to r. So rearranging that and stating what r is equal to, that leads to r equals to 8 times 4, which is 32, and that's 32 over 3. Finally, we can now go back to this formula. In fact, let me box it in red to make it really obvious. We can now go back to this result. And we can state that 12 squared is equal to h squared plus r squared. And r squared, remember, is this expression. Sorry, I said r squared. R is this expression. So r squared will be 32 over 3 squared. Okay? Now, with that in mind, let's see what we get. Don't worry, remember, this is a calculator paper. So you would calculate all of this with your calculator, of course. And before doing so, though, I'll quickly rearrange that to say that h squared is equal to 12 squared minus 32 thirds squared. Finally, I place that underneath the square root to say that h is equal to the square root of 12 squared minus 32 over 3 squared. And at this stage, I would turn it over to my calculator. And I'm sorry I can't make that calculator appear just now on my iPad screen, but trust when I say that I'm currently typing all of that into my iPhone calculator. So that's square root of 12 squared minus 32 over 3 in parentheses. I square that, There we go, and I exit the pair of parentheses and the root, enter. Now, unless I made a mistake with my calculator, I don't think I have, that's equal to 5.49747, etc., etc. So rounding to 3 significant figures. Let's see, well, the third significant figure is 9, and the fourth significant figure is 7, so I've got to round up. So this 9 turns into a 10, which basically turns this into 5.50. And so I would state that the height is 5.50. Whoops, didn't write that very well, did I? I would say that the height, let's see, it's not letting me change, there we go. The height is 5.50 centimeters. And that's the answer. There we go, everyone. Quite a tricky question. Definitely, it's a good one. It really, there's a lot of things going on there. But of course, the key or the bridge towards the solution here was the fact that, you know, in the background, your background knowledge was to do with the formula, this one here, okay, for the slant height of the cone. Since the slant height was technically the radius of the circular sector, and since the circumference at the base of the cone had to be equal to the arc length that we found here, L, it allowed us essentially to get rid of two of the unknowns inside this formula, namely L and R. Once that was done, you know, we can quickly calculate what H has to be. There we go. I hope that helps.